All right, so today is section 3. We're going to relate transformations and congruence. All of our transformations are going to maintain the figure's congruence. We're not going to change the size or the shape of our figures. So transformations in rigid motion. So a transformation in the plane, they're going to move or change the figure to produce a new figure. When we have a rigid motion, it's going to be a transformation that's going to preserve the length, the angle measures, and the area. So basically what we're going to do here is it's going to stay exactly the same size. We're not going to change the length of the sides, and we're not going to change the size of the angles. Everything is going to stay congruent. In some other textbooks, they might refer to this as isometry. Okay, so you might see this. In our book, it's just going to be transformations and rigid motions. So we're going to be transforming our shapes, and we're either going to flip them, turn them, or slide them. And the official terms for that are going to be a reflection, a translation, and a rotation. And we did this last year, I know, in Algebra 1. Where we were sort of introduced to doing transformation on linear equations. When you take Algebra 2, you're going to be doing a lot of transformations on your equations and on your graphs. You're going to be reflecting them. You're going to be stretching them. A lot of different transformations in Algebra 2. Okay, these are the different types of rigid motion. So two figures are congruent if and only if one or more rigid motions can be used to move one figure onto the other. Now, we can do more than one transformation here. So the types of transformations we're going to have are translations, reflections, and rotations. So, a little trick to help you remember what it is. A translation is like a slide. Notice in the word, I've got the letters S and L. So, a translation is a slide. Then a reflection, it's got the letters FL, and this is like a flip. And in this case, this is a flip over, say, maybe the y-axis. So this would be a vertical flip. You can also flip it horizontally. Or you could also flip things over like a line, like y equals x. And then the last one, it's got the T in the middle, the two T's. So this would be a turn. So rotation is like turning the figure. So a rotation. So we have a reflection, translation, and rotation. Again, whenever we do any of these transformations, our figure is going to stay the same size and the same shape. So now we're going to see two examples of a transformation. So in A, what kind of transformation is going on there? Is it a reflection? It's a no. Is it? It's a rotation. Look at this little arc mark or this little arrow. This is indicating that there's a rotation to it. So this would be a rotation. Now, actually in part B, there's actually two transformations going on. So what happened from the blue triangle to the green triangle? What kind of transformation? A translation. That thing was slid over to the right. So that was a translation first. And then from green to red is a reflection. So sometimes more than one transformation is going to occur in your figure. Again, remember your figure is going to stay congruent. It's going to stay the same size and the same shape. Okay. Next, can someone explain why figure A and figure B are not congruent using transformations? Isabella.
First A was reflected and then it was translated.
Okay, now, if it were a transformation, yes, it would be a reflection and a translation. However, let's take a look at this. I know it's kind of hard to tell, but are they actually the same size? No. You can see that this side here looks like it's a little bit longer than this side here. So it's not a congruent transformation because the figures are not the same size. So you could say this side is shorter than this side, and this one's longer. So this is why it is not a congruent transformation. However, if they happen to have been congruent, then what Isabella said was it was first a reflection and then a translation. Okay, but these are not congruent figures, so it's not a congruent transformation. So if the figures are not the same size, then they're not a congruent transformation. Does that make sense? Anybody still need this slide? All right. Now, sometimes you can show a translation by changing the order pairs. Now, I know in your PowerPoint, you've got a picture of one and you want to import it in here. I'm actually going to graph both of these triangles, and then I'm going to show the transformation. However, first let's come up with our new coordinates. So if they give you a rule of what you're supposed to apply to each of the coordinates, you can get the new order pairs first. So what they want us to do is take the x coordinates of each one and subtract 2, and take the y coordinates and add 1. So for example, for this one, -4, 3. If I subtract 2 from -4, I get -6. And if I add 1 to the y, my new order pair is going to be 4. Then if I take the next order pair, the 1, 4, and I subtract 2, I get -1. And if I add 1 to the y, I get 5. And then if I take the last one, I'm going to be subtracting 2 and adding 1, so I get 0, -4. Now, when you subtract to the x, which way do you think we're going to be shifting our figure? When I subtract from the x coordinate, which way am I going to move it? Left or right? Left. Okay. When I add to the y, which way am I going to move it? Up. Good. So this is going to be a shift of the triangle 2 units left and 1 unit up. So I'm going to go ahead and take these order pairs, and I inserted a coordinate plane on my next slide. Point, you don't have a coordinate plane. So now I'm going to graph them. Does anybody have those coordinates? Copy them down. So -6, 4, -1, 5, and 0, -4. Okay, I'm going to graph one in blue and one in red. So the original one, I'll graph in blue. So -4, 3. Put a dot right here. And then 1 and 4. And -2, +2 and -5. Connect the dots, form your triangle. And I'll do the red ones. -6, +4, -1, +5, and 0 and -4. Connect your dots. And you can see how it was shifted. 1 unit up and 2 units to the left. The original was blue and the new is the red. Any questions on the transformations? Yes?
The formula is always the same, subtract 2 and then add 1, or?
No, this was just a specific slide. It could be different numbers. So, for example, maybe on another problem, they might tell you the rule is add 4 to the x and then add.
They always tell you it.
They're going to tell you. They would tell you the rule. And then maybe for the y, maybe you're going to add 2. Whatever they tell you to do to the x and the y coordinates. Generally, what they'll do is they'll show you the original being x, y, and then the new, and what you're supposed to do to each order pair. So this would be a transformation for a slide. Now, what is not a rigid transformation would be like a dilation, where you multiply each one of the coordinates. And then that would change the shape when you multiply. If you multiply by a number greater than 1, it makes it get bigger. If it's a fraction, it's going to be a reduction. So, but that is not a rigid transformation, a dilation. So we're only talking about translations, rotations, and reflections. Slides, flips, and turns. So there won't be too many questions on this. It's just going to basically ask you to identify the different types of transformations. Any other questions on this lesson?